comments, questions. We are going to bring those in during the presentation. Thank you so much for being here.
Thank you so much, Borsika. It's a wonderful, wonderful presentation there, and of course, it's. I think there will be some Legos in this presentation too. I hope that's okay. I'm so happy to be invited here. So happy that all of you joined this early morning for you. As Borsika said, my name is Thomas Engell. I'm an intervention and implementation researcher. I promised to say a little bit about why I put this picture here, and this picture has nothing to do with the presentation I'm going to have today, but this is my favorite place in the world. The picture on the first page here. So this is outside my cabin in the Norwegian mountains in eastern southern Norway, and this is where I do my absolute best thinking, and just looking at this before I have a talk just usually calms me down a little bit. So the agenda for today is this paper titled Common Elements Approaches to Implementation Research and Practice, Methods and Integration with Intervention Science. So I'm going to talk through the common elements concept for the people who are unfamiliar with that. We're going to look at the method that we have proposed in this paper. We're going to look at some practical implications, some limitations, and some recommendations for realizing the potentials of these methods. And I also want to say that this is a conceptual methodology paper. So this talk will be a bit technical, a bit abstract, maybe a bit philosophical. So if that's not your jam, feel free to jump off at any time. But I hope that at the end, we'll see that sometimes getting a bit technical and detailed can help us provide really practical solutions and useful implications for others. And I will pause for some questions halfway through, but feel free to jump in at any time if you want to do that. And of course, I will leave some time for questions at the end. So these are the aims of this paper. We wanted to provide a narrative review of the common elements concept, provide a step-by-step guide to doing systematic common elements methodology that synthesizes and distills the intervention and implementation science literature together. And we also wanted to provide some recommendations for how to advance element-level evidence in implementation science. But first, some acknowledgements. So a grant from the Borchardt Foundation in California supported this work and brought this amazing group of folks together for a colloquium in France in 2019, where the seeds for this paper was planted. I actually wrote the first draft for this paper back in 2015, 2016, but I buried it deep into a folder because it was barely readable. And it wasn't until I discussed these ideas with Nicole, with Greg who's on, and Maya, that I dug it up again. And they were instrumental in bringing this paper back to life, and writing this together with them was really awesome. And I also want to acknowledge the Wedel Jarlsberg Fund that funded my stay as a visiting scholar at the Dissemination and Implementation Science Center at UCSD last year. And I also want to acknowledge that the concept of common elements is not close to new. So Bruce Shorpita and colleagues published about this concept in Intervention Science already in 2005. And my work in this space is greatly inspired by them and many others. And I've also worked with and had discussions with or been inspired by a lot of wonderful folks during the years in developing my take on common elements. And some of them you see listed here. And so thank you to all of them for all of their work. And also thank you to Erica Crable for inspiring me to add this type of slide as a staple in all presentations. And a lot of useful and very impactful work have been done in the intervention science space using common elements approaches. And we have reviewed some of it in the paper, but I also recommend checking out other reviews for more details on that. But in the interest of time, I'm going to skip right to how we can use common elements methods in implementation science. So first, let's look at some background for that. So causality in implementation processes can be a handful. There's so much that can influence implementation at multiple levels, and we can find reasonable explanations of it using a lot of different causal theories. So let's just say that implementation processes are a lot of stuff happening in time and space to implement and sustain something. And that can be activities, events, systems, interactions, relationships, qualities, or other phenomena. And what we can call elements of implementation is everything from discrete implementation strategies, implementation determinants, implementation competencies, relationships, values, or any other relevant part of an implementation process. And these elements may or may not influence implementation mechanisms and outcomes. And they may do so linearly or non-linearly. So the causes can be linear, non-linear, they can be direct, indirect, interconnected, dynamic, emerging, dispositional. A lot of different causal theories can be used. And you can also talk about necessary conditions, sufficient, necessary but insufficient, sufficient but unnecessary, insufficient but necessary part of an unnecessary but sufficient condition. That's a mouthful, and it's a thing. And so perhaps unsurprisingly, implementation processes are often described as complex and messy. But what does these complex messes tend to have in common when they work? And that's what common elements approaches are about. So common elements approaches leverages the evidence base to distill elements likely to be key or influential in a given process, context, or situation. And one could say that that is exactly what implementation frameworks and models provide answers to. And to some extent, I agree with that. And that's part of why they are so useful. But what about questions such as when and under what circumstances do certain implementation strategies tend to work? And when do they not? Do they work as discrete strategies, or do they need to be interconnected parts of blended or more sequential strategies? And when do specific contextual determinants implicate certain combinations of strategies? And does it depend on characteristics of the intervention being implemented or the competencies of implementation practitioners? What exactly are the core elements of effective implementation strategies, and what strategies tend to be adaptable and when? So answers to such questions can be pretty complex and challenging to model generically, in part because they have conditions attached to them and they constantly change. But this is what more advanced common elements methodologies are trying to get at. And in this paper, we propose language, methodology, and recommendations for the field to realize such potentials. So let's start at the basics. So the main feature of the common elements concept is disentanglement or deconstruction. So moving from thinking about interventions and implementations in terms of packages or models to thinking more in terms of the discrete elements, processes, and mechanisms that usually makes up the programs and models. So opening up the black box. And here comes the Legos. So the second main feature is identifying elements that are common across successful interventions and implementations. So these four interventions are different, but they probably have several elements in common. And these are common elements of this selection of interventions. So simply defined, common elements are practices or processes frequently shared by a selection of interventions or implementations. And common elements methods, they disentangle complex interventions or implementations into discrete elements and then describe or evaluate the relative merits of the common elements across the scientific literature. And depending on what theoretical orientation you come from or methods that you use, these elements are assumed to have certain qualities or characteristics about them, such as active ingredients, essential elements, evidence-informed elements, or evidence-based kernels, for instance. But basically, these methods synthesize and distill research to extrapolate what works. That's the basic concept. And there are several methods you can use to identify common elements. And the traditional ones that you see listed here are most focused on identifying discrete practice elements that commonly work. So what we usually term active ingredients. While recent developments are also focused on configurations or combinations of different types of elements. So in the method that I developed, we review combinations of different types of intervention practices, processes, contextual characteristics, and discrete implementation strategies. And we do that to identify the combinations that tends to work, not just a single element. While Furukawa and colleagues do some amazing reviews where they test the relative effects of elements or configurations using a method called component network meta-analysis. And they also test conjunctions with client characteristics using individual participant data into the meta-analysis. And in intervention science, results from these types of reviews have been used in a lot of different ways, such as directly for dissemination and implementation in practice. We can also use the results to sort of trim complex interventions and programs, so discarding the likely unnecessary elements and perhaps adding the missing ones or the contributing ones. You can also implement more flexibly and contextualized because these smaller entities are more easy to integrate into a more dynamic practice. You can also use them as building blocks to design or redesign more tailored interventions or other models of implementation in practice. They can inform experimental studies and other more like fine-grained testing of elements and mechanisms. And I will just call the methods that we present in the paper for Common Elements 2.0. So sort of like a next step for common elements methods. And the main features here are a high quality systematic review or other quality assured databases. It's based on synthesis, coding, and integration of intervention and implementation science literature. So reviewing it together. And these blocks are important. So it's about deconstruction, about commonalities, and configuration. And configurations using network architecture, and I'll come a bit back to that. So these methods are just as focused on what and how elements and components make up meaningful wholes as they are on discrete elements and components, meaning the parts. And one of the reasons for that is that we aim to add to our understanding of the how, why, and when interventions tend to work, to complement the primacy to the whether and how often that we have traditionally used most in intervention science. And that also allows us to unveil adaptations that tend to be favorable under different circumstances. And these methods can be used really pragmatically, but they can also be used really advanced. It depends on the aims of the work. But these methods are still pretty limited by the primary studies available and the details and data reported from them in the literature. And a key step in this method is deconstructing the things and the stuff that we do to get people to do the things, meaning for instance, the interventions and the implementation strategies, and deconstructing them into their elements and components. And I've done conceptual work on that using logic about the relations between parts and wholes, which is used across different scientific disciplines, where the appropriate level of deconstruction depends on on objectives of your work and what you believe about the nature and composition of the things, what's called meronymy and partonomy. So do we believe that the thing is a sum of one or more active parts or ingredients? Or do we believe the thing or system as a whole is more than the sum of its parts? Or do the things, this causal powers or contributions tend to be triggered by something specific, such as a specific set of parts or configurations? So it's a bit technical, but it's sort of facilitating for different types of causal theories to be used in the same framework. So it's sort of a theoretical foundation to avoid making the methods themselves constrain or lead the theory, which then facilitate the opportunity to synthesize and integrate evidence from different ontological and epistemological views. So in other words, implementation science is young, and there may be important and influential elements at play that we have not accurately articulated or theorized yet, but we want to keep this method open for such novelties, so open for finding the unknown unknowns. But this is not at all an attempt to replace any established IMSI constructs. It's just taking a step back for doing these types of reviews, and we can apply more theory when we conduct the reviews or when we interpret the results. So with that logic as a foundation, an implementation element will then be any meaningfully distinguishable part of implementation at any level of discreteness. So an element is a part of a whole that is in itself is also a meaningful whole. And an example of that can be that a provider's self-efficacy towards an intervention may be an element of an implementation mechanism, while an implementation component can be any part or ingredient of an implementation element. So a component is not necessarily in itself a meaningful whole. We use that term when a second level of discreteness is needed, or to describe the parts that depends on other parts to compose or maybe catalyze a whole. An example of that can be a brainstorm session for implementation barriers, which is a part of a readiness assessment. And we also distinguish between different types of elements and components. Practice elements are or describe things people do. Process elements are how people do things or how things unfold or emerge, while context elements are circumstances in which things are done, unfold, or emerge. So here's an example that includes all of those types of elements. So conducting a readiness assessment in facilitated collaboration at a local community mental health clinic using workshops, a professional facilitator with trust among partners through collaboration. So all of these elements create a process together. And elements can be core elements, they can be evidence-informed elements or evidence-based elements based on some criteria. And there's more definitions and examples of that in the paper. So that was a lot of information in a short period of time. Are there any questions before I go on?
So we do have a couple of questions. I will start with the one that we just received from Greg. One of the weaknesses or areas for development in implementation science is the rigorous assessment and reporting of implementation strategy fidelity. How would implementation strategy fidelity assessment work or be optimal where the common elements approach is being used?
Yeah, that's a great question. And in the later part of the talk, I will go more into that. But just to address it quickly now, at the exact same way that we would handle fidelity to intervention practices, the same fundamental system here will be used in the same way, same conceptualization, just that instead of the interventions, it's towards the implementation strategies. And a big missing link from all systematic reviews that we have on interventions, and we have even fewer on implementation strategies, is this discrepancy between what is reported that was done and what was actually done. So by providing more detailed process data about fidelity to both interventions and implementation strategies, we will start to decrease that discrepancy, or at least make it transparent. So that's one way, and I will get into more details later, and there are some details in the paper about that. Does that answer your question a bit, Greg?
Yeah, it does. It's just something we've been kind of wrestling with, that we think the field needs more focus on really understanding fidelity to implementation strategies, not to intervention. Well, you need them both, but yeah. Intervention fidelity and implementation strategy fidelity. So thanks. I look forward to hearing more.
Yeah, I totally agree, and thank you for bringing that up.
Let me see. I had one more question for you, but I want to see whether others would like to jump in with any questions before I ask my question. Okay, then I will ask it. So I really appreciate it, and I wrote down a number of slide numbers of, what are the sources of disentanglement information. This is mostly, expert opinion, etc. I know that most of our work is with partners now, and especially community partners. Should we include their perspective as we are doing this work? And how do you think about this?
Yes, absolutely. When that is appropriate for the goals of your work. If your goal is just to describe the literature, then maybe it's not necessary. But if you want to end up with actually finding stuff that you're going to implement in real world practice, I would recommend having your partners on your team, the partners outside in the real world, with you from the start, and helping you refine taxonomies and stuff also when you go into to review the literature. I'm also going to go a little bit more detailed into that later, but excellent point. Yes.
Wonderful. Thank you. I don't see other questions in the chat. Let me give one more chance to those who would like to unmute and ask something, and then hand it back to you. I think.
All right.
Back to you.
I'll jump into the actual methods then. So let's do a step-by-step guide to these types of common elements reviews. So the first step and the second step is basically search and selection as regular high-quality systematic reviews are done, or you can use existing reviews or use databases. But one substantial difference can be that doing these types of reviews requires gathering more material and data than usual. So it often includes things like supplementary files, reports, manuals, implementation plans, open data, as much information you can get. And that often includes contacting corresponding authors and asking, hey, do you have more details about the implementation, or do you have more details about your effect sizes and stuff like that? Well, step 3 is preparing and piloting a coding system for coding all the elements. So you have to create a conceptual framework and system for coding that fits your objectives and your theoretical perspectives. So you define all the elements, components, determinants, and outcomes that you think are relevant for your study. Here we recommend using existing taxonomies and ontologies when they are relevant, but also deviating and reporting it when you find them inappropriate. And an important point is preparing for adding anticipated elements during coding to reduce popularity bias. So we want to code both deductively and inductively. I'll come back to that later. Then you have to prepare some matrices or databases in a way that let you organize the data appropriate for the algorithms and analyses that you want to use. In our method, we have a sort of a network architecture that we use. And then it's piloting and adjustments before you get to step 4, which is the coding iterations. And then you have independent coders coding all relevant study materials. Any conflicts resolved through discussion with the supervisor, and we also gather some coding metrics for learning. You also have to recode for any unanticipated elements included during the coding procedure. So if you find and agree that there's some elements that you didn't know about before the study, then you have to go back and review all the studies to see if they have these elements as well. So it's a bit labor intensive, but that's how it goes. And then step 5, you apply algorithms to identify the common elements and configurations. So we use a set of frequency-based algorithms to then identify in your database or your coding matrix or whatever you use, identify common elements and common combinations of elements across the studies. And then we identify specific configurations of common elements. So for this type of setting, this type of problem, this type of determinant, whatever you're interested in, you identify common elements for that specific configuration. And you account for inclusion in effective interventions and implementations versus in ineffective or with negative effects. That's also important. And then based on all of this, you formulate hypotheses based on common elements, combinations, and configurations. And then you move on to statistical analyses. There's much more details about these steps in the article, so this may be going a bit too fast, but there are several possibilities for statistical analyses, and I mentioned a few here. So 3-level meta-regression analysis can test how the inclusion and exclusion of common elements and common configurations are associated with effect sizes for different outcomes, and how other elements moderate the associations. And our fantastic statistician, Tore Venstrevarsen, has developed a freely available Shiny app in R for doing those analyses. You can also use component network meta-analysis to estimate the relative effectiveness of the elements and combinations across the studies. And you can use this, do this by using Bayesian statistics or more traditional frequentist methods. And common elements reviews can also feed into data ecosystems with machine learning, and we will get back to that in a bit. I just also wanted to mention that you should, if you do these reviews, you should include and encode all studies regardless of effects if you can. So as a general principle, don't exclude studies or conditions that are less effective, ineffective, or harmful when reviewing common elements, because exclusion can skew results and increase what I call popularity bias, which is the tendency of some elements to be frequently included in interventions and implementations based on popular opinion, regardless of effectiveness. So just including like winning studies or conditions, that can be appropriate depending on the aims of your review. But as a general principle, include them. There's much to learn from ineffective studies. One example here, in a common elements review of academic interventions, we found that structured tutoring was the #1 most common element of effective academic interventions. But when accounting for inclusion in ineffective studies also, structured tutoring did not even make the top 5. Here's another example. This is a common elements review of treatment programs for adolescents with mental health problems done by a great colleague, Line Solheim Kvamme. And The most common practice elements of the winning interventions in a review were training in behavior regulation and mindfulness awareness. But when inclusion in less effective and ineffective studies were statistically accounted for, none of them were associated with effects or outcomes. When she accounted for both, then emotion recognition and differentiation and psychoeducation was the much more promising elements. So I wish I could present actual results from fully utilizing these methods on implementation strategies. We have tried, but for the time being, there's limitations in the literature available and the details reported from it, which has made that difficult. But things are underway, and it's looking better for every year. When we get new studies, we'll report much more. But for now, we will have to deal with a hypothetical example to envision the possibilities that these methods can give in implementation science. So say that we want to unpack the complexities of external consultation. We have a common elements review, including above 100 richly reported intervention and implementation studies, where the external consultation have been experimentally tested or used. I just say we're not there yet, but we can be pretty soon. So this is the potential results we could get from such a review in the future. So we will get a descriptive overview of the most commonly used consultation elements in implementation processes with successful outcomes, adjusted for use in implementation without successful outcomes and with negative outcomes. So sort of this is what tends to work in research. And then we can sort and extract based on any coded characteristic. So this is what tends to work given specific constraints or circumstances. So for instance, for different outcomes, for a type of intervention design, or categories of specific implementation determinants. And then we can extract the most commonly successful combinations, configurations of different types of elements and characteristics. So in context X for intervention type Y and population C, what's the most commonly successful combination of consultation elements and other implementation strategies? How are they most often carried out when they work? And what adaptation options would likely be useful in this situation? And then we can do statistical analysis of effects and associations. So the 3-level meta-regressions could estimate implementation or intervention effects with and without specific practice elements and test associations between specific elements, practice elements, process elements, and context variables. And the component network meta-analysis could estimate the relative effectiveness of the elements and different combinations. So how can we use this type of knowledge? So there are several existing dissemination tools available where common elements results can be useful. For instance, element level evidence could be disseminated in evidence maps, clearinghouses, libraries and repositories, and other formats. And there are several online repositories and clearinghouses that disseminates guides for evidence-based programs. And such guides could also disseminate which implementation elements commonly work to implement and sustain these programs. But the perhaps most promising type of dissemination is likely collating mega reviews or continuously feed coded data into data ecosystems with network architecture that are designed for machine learning. And I am no AI or ML expert, but I use the term data ecosystem because I also envision feeding data from feedback systems in real-world practice back into the system to continuously improve learning and predictions. And in these days, the vision is perhaps best depicted with a chatbot. So picture that you can ask what commonly works to address your intervention and implementation problem. and you will be provided with practical answers, options for tailoring, and also the scientific and practical basis for the answers and options that you get. And the Human Behavior Change Project is a pioneering example from behavior change science that is pursuing several of these ideas. This project is led by Susan Mickey. And if you're interested in this, I suggest, I can recommend checking out that project. But even without the data ecosystems, just doing the common elements reviews can also have useful practical implications for implementation practice. So evidence-informed, we can use them as evidence-informed building blocks for co-designing implementation strategies or processes with our partners. So for instance, given these circumstances, which elements tend to be combined, what can we adapt, what leeway do we have, what competencies and relationships is likely required for success, etc. You can also have implications for training and education and capacity building. If you focus training on the elements that most commonly work, you can discard some that commonly doesn't work. That can be both generically or more context specifically. That may be an efficient way to train for more breadth and depth in expertise instead of having to teach everyone everything. And it's also well fitted for stepwise and needs-based approaches. So you can start with some elements, then you can take some others, or you can choose the elements that most appropriately fits your needs right here and now. And maybe the needs change and you have to do it stepwise. It can also be building blocks for system, service, and model design. So it might help stimulate innovations while also leveraging the evidence we already have instead of just disregarding our evidence base. For instance, designing or altering systems and implementation models with elements that tend to be associated with desired outcomes. And Bruce Sherpita and Eric Daleiden has some great examples in intervention science on how we can use elements to intervene more on system level. We can do the same in implementation science. And some practical applications for research can be used to provide an overview of element level evidence. What do we know? What do we don't know? And then we can identify knowledge gaps. We can generate hypotheses about core elements, active ingredients, mechanisms, and different types of configurations or systems of elements, and then inform experimental testing. And it can also be evidence-informed inputs for different types of causal modeling and diagramming that I like to do a lot, really useful for that as well. But there are limitations to this, as with all methods, but the biggest limitation are the studies available and the details and data reported from them, and especially regarding process and relational or social aspects of interventions and implementation. And there's also the challenge of inferring element level causality when the studies in the reviews tested complex packages or of interventions and implementations. That's not impossible, but it has some assumptions to it that can be challenging. And as with all systematic reviews, these reviews are affected by publication bias and also by popularity bias that I mentioned. And for the time being, without more automation, which is perfectly feasible, it's really labor intensive to do these reviews really detailed. So I will briefly go through some recommendations for researchers and for scientific journals that can help realize the potentials of this or other types of element focus synthesis approaches. You will find more details on this in the paper, but in almost all common elements reviews, you will find the following sentence: limited by poor reporting of intervention details or data, And in work where our work, will we also look at the implementation elements, that lack of reporting is even more profound. But it's getting much, much better every year. So that's good. So we recommend track and report element level details about all relevant intervention and implementation practices, processes, and context characteristics in your studies. So basically, we need to capture and report as much information as possible about how important elements and outcomes occur, unfold, and emerge in time and space. And that likely includes more use of more untraditional ways of collecting data, such as experience sampling, and also mixing with method studying more subjective experiences. And there are more details about these different methods in the paper. And here, just to come back to your point, Greg, fidelity to implementation strategies, a big part of this. We need to capture more of that. And that can be done also in similar ways. This is more focused here on intervention fidelity, but it's practically the same for implementation strategies. And we can't put everything in manuscripts, so I tend to say abuse supplementary files to report details. There's limits to manuscripts. There's rarely limits to supplementary files. So if the reviewers say you have too much details, say, okay, that's fine, I'll put it in the supplementary files, because we need those details. And use current reporting standards and taxonomies when they are appropriate, and add to them and deviate when necessary and explain why. And another important recommendation, publish as many details about unsuccessful intervention and implementation as for successful. There's much to learn from our failures. So the file drawer problem, an unethical waste of opportunity for scientific learning. And there are open journals that we can use when it's difficult to publish our paper in a peer-reviewed journal. Third recommendation, make data available when ethically appropriate. Some tips there: plan early at design and planning of study if possible. Write it in your grant. Give an incentive for following that up, and also individual participant data when that is possible and ethically appropriate. And the last recommendation is test hypotheses derived from common elements reviews experimentally, because then we will sort of test this concept as a theory, but at the same time we will gain causal knowledge about elements and mechanisms. So it's a win-win situation there. And we can use different experimental designs for that, such as factorial trials, micro trials, smart natural experiments. But also it's important to complement mix with designs fit for studying processes, mechanisms, dynamics, more subjective experiences, and other methods from multiple perspectives. So I'm coming in for landing here, and in conclusion, the more advanced common elements approaches, they can help synthesize and distill evidence into practical implications. They can generate evidence-informed hypotheses about key elements, key processes, and mechanisms in interventions and implementations. And they can facilitate evidence-informed tailoring of intervention and implementation strategies to context. And we have 4 recommendations, or 4 needs really, for getting there. Track and report as much details as possible. Also publish our failures, they're not failures. Make data available and test hypotheses derived from these reviews from different causal perspectives. And all references I've used in this talk is listed in the paper, which is open access. So yeah, I think that's it. Thank you so much for listening. And if there's any questions, any thoughts, any comments, I'm eager to hear what you have to say.
Thank you so much, Thomas. I suspected and was not disappointed that this was an amazing way to close our series in this academic year. Thank you so much for sharing your paper. We have some questions coming in, so I'm going to facilitate the discussion. I wanted to first see whether anyone would be willing to unmute and ask a question. I generally try to give more time, but we don't have too much. So I am just going to jump right in. Michaela, I don't know if you're in a position, but would you like to comment on this comment? Just heard this acronym FAIL, first attempt in. Did you want to say more about it?
Yeah, hi, everybody. We did just hear this on an earlier, oh, sorry, I'm trying to start video too. Just heard this on an earlier session and I loved it. It was part of human-centered design. And they said this publication bias that you all talked about and the fact that we can learn so much from initial attempts to learn is really an interesting way to reframe that fail. And I think that that's an area that we have just an overwhelming area to grow because there's such publication bias around this. I wondered if anybody knows of any repository, of brave researchers who are willing to share failures. Where do we even find those if they're not in the public record?
Yeah, that's a good question. I don't know of any repositories, but I know that I see more and more journals advocating for publishing null results, which is great. But I've also heard from people trying to publish in the same journals that it's still difficult. So that mechanism is perhaps not perfect, but I know that open journals such as the RxIV, there's papers there. If you search there, I think you will find some. I have a failure paper in RxIV, but I don't know of any repositories on it. But it would be cool to collate it in some way, compile it. Absolutely. And if we create databases such as what we suggest in this paper, then we can just sort on it and get all the failure results we want. So, yeah.
Wouldn't that be a wonderful movement in our human existence as well, just beyond research? Greg, you have a comment, I think, that is related. Greg, I don't hear you.
I think you're muted, Greg.
One place we could look, although it would be maybe labor intensive, is the clinical trial registries. At least for projects funded by the U.S. National Institutes of Health, almost all of our implementation strategy studies are considered clinical trials, whether or not you're collecting client outcome data or not. So those registries would have to report their outcomes even if they're null, but I don't know that that's systematized in any way.
Yeah, that's a great idea, and there's multiple registries we could check, and if they have such a function, that would be incredible. I'm gonna go have a look after this.
I think another related comment might be that links back to your recommendation, Thomas, that we are not doing a great job of reporting on a diverse set of outcomes, even in implementation studies, and especially not adverse outcomes that came up, unexpectedly, which certainly would be helpful to know as we are developing this kind of inventory of knowledge.
Absolutely, and that's a great comment. And I think it was Michael Pullman, who published a great paper this year or early last year about the negative consequences, the unseen negative consequences of implementation work. And there's a list of around 70 negative consequences that are potentially important outcomes to measure. That's a list to take some inspiration from. But yeah, I absolutely agree. Adverse outcomes is really important, not just in, from the beginning.
Super. Thank you so much. David?
I just wanted to acknowledge there's going to be a report coming out from the RAND Corporation. My colleagues here at the University of Pittsburgh in our D&I lab, we collaborated on a landscape review of implementation strategies, and it wasn't really supposed to be a true systematic review, but we ended up looking at combinations of strategies, and we used the REAIM framework to look at different types of outcomes, including health outcomes, implementation outcomes, but also looking at effects based on REAIM. And we did find a lot of negative strategies out there. It's surprising how weak some of the outcome reporting is for early implementation research. We focused our review on 2010 to 2020. That database should be online by this fall. We're still finishing our examination of international studies, but we completed our examination of US studies earlier this spring or winter. And probably looking in the neighborhood of like 130, 140 studies total that will be published, but there'll be visual depictions of combinations of strategies used. All I can say, it's very complicated, and it's not going to be perfect or pretty, but I think one of the things that's really important for this common elements approach is to work towards refining some of the different definitions of strategies or determinant frameworks, or even the levels of analysis. So like Mitchie's work, Susan Mickey's work is a little different than the ERIC framework. And we use the ERIC framework to describe strategies, but it was definitely not comprehensive enough to describe all the strategies used out there. So look for that. I'll put the primary investigator's name from RAND in the chat if anyone wants to reach out to him.
So
Right. Yeah.
I'm sorry, David, there is a recommendation that we found our September speaker for this group. I would love to, please let me know if that's realistic. Just let's email offline about that.
Yeah, that sounds really interesting. I would love to come to that talk and hear about that. And I completely agree with you. And that's one of the reasons that we sort of made as much a theoretical framework for reviewing elements as we can, because then we can actually review all the research that uses REAIM, ERIC, the behavior change taxonomy, all of these, even though they are sort of theoretically latent because they have used the framework, we can synthesize it together. And then we can interpret theory afterwards if we want to, but we're still able to synthesize it. So yeah, I completely agree with you.
Wonderful. Thank you so much. Very rich discussion. Thomas, we really appreciate you closing us off. If you would like to be added to our list serve, you will receive invitations for future calls. You can opt in via Kara, but we were really grateful for all of you who have been attending these sessions over the past academic year and the past, now I think 6 years, and we look forward to reconnecting in September. So thank you, Thomas, again. Thank you everyone for being here, and have a wonderful summer.
Thank you so much.